Okay, our next topic on the principles of financial mathematics is compound interest. Compound interest is mostly used form of interest that banks use at the moment, and it has been for a long time because they make a lot of money off you people. And the interest can be compounding annually, monthly, and even daily. Usually it's on the daily for bank loans. And at maturity, so maturity means that when we're about to finish the loan or the investment, it's agreed on by the two parties, being either you and the bank or the bank and yourself. So that's the way it works. Now with compound interest, it earns you more money if you invest your money, because if you were talking about simple interest, what we did before, it's flat rate, fixed interest rate every year on the original amount. However, this type of compounding interest is based on the amount that is available at the end of the year every year. So if you invest 1,000 at 10%, you're going to get 1,100 at the end of the year. Then the interest is going to be worked out in the second year on the 1,100 and not the original 1,000 like it was in simple interest. So you pay more interest, a lot more interest, if you have borrowed your money as well. So let's take a look at an example of compound interest. Okay, the rule is A equals P multiplied by 1 plus R on 100 all to the power of T. Now, A is our total amount of money. And usually we can write also AN, little subscript N, to say, after how many years as well, but it's not necessary. P is the principal amount, or the initial amount that you either borrow or you invest. And R is the interest rate, which is usually as a percentage. And your T is for time. That is always in years, guys. Do not forget that. And if they ask for monthly, you need to convert that. Right, let's take a look at a question. Determine the amount of money accumulated after, now saying accumulated after 4 years if 10,000 is invested at an interest rate of 9% per annum, that's important, that's per annum, compounded annually, and give your answer to the nearest dollar. So this is compounding every single year for 4 years. Very important. The wording is important. Now don't forget, in the VCE exams, whenever they say compound, simple, flat, fixed, you notice I've underlined compounding annually. That automatically tells me that it's a compound interest question. That's what's important. Now let's do this question. Need to write the rule down first. A equals, then you write P times 1 plus R on 100, and the bracket bit is all to the power of T. Okay? Make sure you write, and I want you to write your formula down all the time. Very, very important. Now we need to also label our variables. We've got variables here, A, P, R, and T. So, when you have to label the variables, you've got to go back to the question. 4 years, well, straight away I can put the 4 in the T, can't I? That's just 4 years. 10,000 is the amount that I am investing or borrowing. In this question, I'm investing it, so 10,000 goes under P. Our interest rate is, 9%, and our amount is the question mark. That's what we're trying to find. Now, you substitute this in. Don't forget, I'm showing you how to do this by hand. You don't have to do this by hand all the time. I'll show you the steps a bit later on. I'm working with Mr. Denatale at the moment, so we'll show you the steps a bit later on, but I'm interested in so you know the concept of how this formula works. So you substitute P for 10,000 in there, 1 plus R on 100, which is 9 over 100, all to the power of 4. This is compound interest. Now, all you have to do is go to your graphics calculator and just type that in exactly as it is, as you see it, and you punch it all in, and you'll get the answer as being $14,115.80. Now, what that is saying to you guys is that if you went and got $10,000 and you put it in the bank and you left it for 4 years, right, at the end of that 4 years, it would have grown to $14,115.80. Now, what is important? I got the answer, yes. Am I going to get it right? No. Why? What does it say? Give your answer to the nearest dollar. So, write that down. That will equal to what? 14,100, and it's 80 cents, isn't it? So the nearest dollar would be 116. What? So I'll say it again. $14,116. That's what it grows to. Now, part B says, determine the amount of interest earned. Well, I had 10,000. Now I've got $14,116. How much do I have, guys? You subtract the two, don't you? So to work out your interest, it's just A minus P, right? Which is 14,116 less 10,000. And you don't need a calculator for this because it works out to be $4,116 in interest. Not bad for 4-year investment, is it? Very good. Right, let's move on to the next question.
Just make sure, guys, these are worded questions. Now, we haven't got room here, but make sure that you actually finish them off by saying, for part A, total amount earned is, after 4 years, is $14,116 in words. And the interest earned for part B is $4,116. So finish them off in words.
Right. Compound interest is not always calculated yearly, so the formula changes to reflect this. Now, you don't have to use this formula. You can do it from the previous formula by manipulating your rate and then multiplying your time. But Mr. Denatale likes to have it up like this, so that's fine. So if you can see here, if it was in months, all I would do is my rate divided by the months, the number of months. How many months in a year? 12. And then what you do, while you're dividing it by the months, you have to multiply it by the time per year the interest is calculated as well. So that depends on the question, okay? Very important. Now, let's move on. Determine the amount accrued if 2,700 is invested at an interest rate of 6% per annum for a period of 2 years compounded monthly. This is a very easy question. Now, saying compounded monthly, like, I mean, I already know that 2 years, 1 year has 12 months, so 2 years is going to be 24 months, isn't it? So, anyway, let's keep going. A equals, you've got to write out the formula. P multiplied by 1 plus R on 100. It's the same one, but the R now has R divided by N, all divided by 100, all to the power of N multiplied by T, and N is the number of months here, isn't it? N times T. So, write the variables down again. A equals, P equals, so on and so forth, as Mr. Denatale is doing at the moment. Now, the A is the amount that it accrues to, so it's growing. This investment is growing, isn't it? So, that's the question mark. P, we're investing 2,700. Our interest rate is still 6%. Now, as I was saying, you can use the other formula, you can just divide by 6 here, but we'll leave it to do the formula this way. N is, well, it's compounding monthly. There's 12 months in 1 year, so that means when you multiply it by the T, that's going to be 24, isn't it? And the T is for 2 years as well. So Mr. Denatale is just writing this out nice and neatly for us here. Now, the next thing to do is substitute into the equation. So we've got 2,700 multiplied by 1 plus R divided by N, 6 divided by 12 is a half, isn't it? Or you can just write down 0.5 if you like, Mr. Denatale, but I think Mr. Denatale will do that in the next step. And then multiply that by N times T, so it's 12 times 2 years, which will give us as 24. So really, we're still using the same formula, aren't we? But we're just we're putting it all into this one. So next step, 2,700 multiplied by 1 plus. So I'm actually just going to type this at the same time into the calculator.
While Mr. Addy does that, when you do it on your calculator, make sure you have the little witch's hat, so the power. You might, depending how your calculator works, have to put this in brackets. Usually it comes up with a little box and the inspires, and you just put the 12 times 2. But if not, if you're using a different calculator because you're saving your calculator in the exam, make sure you put that in brackets with the power. Okay, so be careful there, please. I'm sure Sue's almost finished.
I'm almost there. To the power of, what was it, Mr. Danatale? 12 times 24. So you punch that into the calculator and you get an answer of $3,043.33. Now, that's just by punching it into the calculator and you're getting these answers. Now, guys, there's a real quicker way to do all this stuff, and we'll go through that step in a minute. Right, have I answered the question properly here? It doesn't say to the nearest dollar, doesn't say 2 decimal. So I've got it to 2 decimal places. That's what the calculator gave me. That's the answer I put there. But if they've asked you, determine the amount accrued, the amount accrued after 2 years is $3,043.33 for an initial investment of $2,700. Next question.
Please don't make sure as well, I'm just going to butt in, so please don't make sure that if it's 33 cents, as it is here, we don't round to 35. It's not, we're not selling anything. This is what the banks actually do. If it's, they keep it to every cent that they work out. They don't give you any more money. They don't give you any less money. They give you exact money. So 33 cents stays as 33 cents.
All right, next part of the question. Determine the interest earned. Again, guys, I had $2,700. Now I've got $3,043.33. Subtract the 2. And what are we going to get? $3,043.33 less $2,700, and you just punch that into the calculator or do it in your head and you get $343.33. Fairly easy, isn't it? Not too hard. That's compound interest. Okay, on the calculator. Now this is the way to do it on the calculator. So you've got to start a new document by pressing Control N. You select the Add Calculator, menu 3, then number 1, because the menu 3.1 goes into the algebra and gives you the solve. So when you punch that into the calculator, the solve comes up with the open bracket. So all you've got to do now is put in 2123.4. So I'm just giving, this is the example. So in our example that we had, we would have put in here 2,700, wouldn't we? This is based on a question, isn't it?
We were finding our A, so we would leave our A, and we had, so I'll do it.
Yeah, but what I was saying is that these figures aren't based on the previous question that we had.
No, that's right.
This is another question.
Yeah, but we were finding our A in our previous example, yeah. So we would have solve bracket A equals 2,700, that was the previous example that we did, times, and we had 1 plus our R, which was 6 divided by 12,
yep,
divided by 100.
That's correct. To the power of?
Power of 12 times 2.
And then comma.
And we put our comma, because now the calculator wants to know which letter are you finding, which variable, and of course our variable is A. There it is there. And you close your bracket and press your enter.
And then that will give us the $3,043.33. And this calculator is brilliant because it does it all for you. However, Mr. Danatale, what they have to remember, if they're showing the examiner working out here, they still have to write out the formula, label their variables, then solve, write it down, and then give the answer, and then also write the sentence at the end of it.
That's right. And you can just, after you've shown the formula and you put your variables down, this, and you're pressing your solve, it comes up solve with the bracket, and you just fill it in as I just did there, right there, and then put your answer down.
Okay. And that's the end of compound interest. Exercise 20C, we want you to have a go at all the questions. Don't forget, ask us in class if you have to find the value of R, the value of T. You use exactly the same formula. You don't have to change it, and you can do the algebra and transpose it. But Mr. Danatale will sort of say to you, hey, we can do this on the calculator, so there's no need to worry about that sort of stuff.
That's right.